So we need to look at this case of more than two values for the target. Okay. Two cases. One is that the target is ordinal, where the value of 0 is smaller than value of 1, and then 1 is smaller than the value 2. And we will also look at a nominal target where there is no ordering among these values. There is 0, 1, 2, or there is no less than or equal to kind of relationship between the values. So that's what makes it a nominal variable, right? So how we calculate propensity for each of the values of the categorical target is going to be different. Okay, the way we handle ordinal is different from the way we handle nominal. Ordinal is easier because of this inherent structural relationship, okay, among the values, and whereas nominal it's a little more involved. Okay, so what we have to do is to look at this, convert the target into a binary target. Okay, so in ordinal, what we will do is we'll define two different models. So the first model will be, okay, let's call this model apply equal to 0, right? So in this model, our target will be, so we will define a new target. So apply 0 is equal to 1 if apply 0, okay, otherwise equal to 0. Okay. So if apply 0, this new target will be 1. If it is 1 or 2, it will be 0. So now it's a binary target, right? So here for model 1, apply 0 is equal to 1 if apply equal to 0, 0 otherwise. So what that means is that we can set this target up by looking at the apply column, okay, and check it whether is it 0. If it is 0, then let's code this column as a 1. Okay, otherwise it's a 0. So copy that. Okay. So now we use this as the target and then develop our model. Okay. So here we have 3 predictors, right? So this will be PARED. This is for public and GPA. All right. So we have the intercept here. So we need to set up the logistic model. So this will be B sub 0, and we'll absolute reference that, okay, plus some product of the slope coefficients, okay, and we need to absolute reference that with these three columns. These are the three columns of values, right? So intercept plus sum product of the coefficients with the values of the three predictors. So that's our L, okay, the legit function. Okay, so far? Okay. And then we do our exp to the power of minus L. Then y hat is 1 over 1 plus e to the power of minus L. So that's the probability of target being equal to 1. And then we have the probability to the power of y, okay, times 1 minus probability to the power of 1 minus y. Okay, so that is the probability function, probability for that record. What is the probability that that target belongs to the value in the observation? Then we have a log function, logarithm of that. Okay. And then we can sum that logarithm here. Sum of that column V. So that's our function for minimization, right? So then we run solver, we want to maximize that, changing cells of these 4 cells, intercept and slope coefficients, right? And then we need to uncheck that. Okay. So maximize the likelihood function and determine the values for the B coefficients, and so we have an estimate. So that is model 1, where the target is apply 0.